So let's go ahead with the class. So a very good afternoon or good evening to one and all. So we are dealing with the equilibrium lesson, right? So in the previous session, we have discussed about the acid-base theories definitions. So there were three theories: Arrhenius theory, Bronsted-Lowry, and Lewis acid-base theory. And according to each people concept, we have seen the definition for acids and bases. So according to Arrhenius, acids will give hydrogen ion and bases will produce hydroxyl ion. And according to Bronsted-Lowry, acids will donate hydrogen while the bases are proton acceptor. Okay. And according to Lewis theory, acids are electron pair acceptor and the bases are electron pair donor. Okay. So these are the three theories we have discussed. And also we have studied the pH formulas, right? So to find out the pH, the formula is minus log of H plus concentration. And for finding out the POH, it is minus log of OH minus concentration. All right. So these are the two formulas we have seen in in the previous session. So today we are going to enter into the pH of strong acids and strong base. Okay. pH of strong acid and strong base. So let me show you the pH scale. So this is the pH scale and all of you can able to see the picture, right? So from 1 to 7 pH, substances are acidic in nature and 7 means neutral, and after 7, they are called as basic, okay? Basic or alkaline in nature. So you can see that energy drink, the burger and the coffee and the purified water, all these are coming in the acidic side, and all the fruits mostly, they are coming in the alkaline sides. Got it? The spring water and all the fruits, they are coming under the basic side. So now moving ahead with the pH formula, we will solve one question and then we will go for the next. Now coming to the concentration of hydrogen ion in a sample. A sample means the soft drink sample. So the concentration of hydrogen ion in the sample is 3.8 into 10 to the power minus 3. What is its pH? What is its pH? Can you find out? This is the hydrogen ion concentration, H plus concentration, and they are asking us to find out the pH value. So how to find out? We know that pH is equal to minus log of H plus concentration. So substitute the value in place of H plus. So we will arrive at this. So now this log is common for both log 3.8 and log 10 to the power minus 3. And here we have multiplication symbol. So put plus. So it is minus of log of 3.8 plus log of 10 to the power minus 3. So you can take this 3.8 as 4 and the log 4 value will be mostly 0.589 kind of thing. Okay, it is actually 0.6. And since it is 3.8, you can reduce from 0.6 to 0.589 kind of. And the log of 10 to the power minus 3 is equal to minus 3. Okay, I told you, right? Log 10 is equal to 1. So it will be minus 3 as the answer. Now add these two. You will end up with 2.42 as the pH value for the soft drink. Okay. So can you tell me whether it is acidic or basic? The pH is coming out to be 2.42 for soft drink, right? Is it acidic or basic in nature? Is this pH acidic or basic? Soft drink is acidic or basic? Very good, Trisha. Yes, Kartika, it is acidic. The soft drink is acidic with the pH of 2.42. Yes, students, very good. So this type of questions are very important. Okay, it is a straightforward question. We are just going to take out the given concentration value and apply it in the formula. Okay, the only thing is the calculation part. And I hope you guys can able to do the calculation also, right? I have taught how to take the log of m to the power n, and I have given you some log values also, right? Did I give you the log values before? Did I give you the log values before? For log 10, the answer is 1. And for log 2, it will be 0.3. And for log 3, it will be 0.4. And for log 4, it is 0.6. Okay, 5, 9 kind of. So you can take it as 6. So like this, for some numbers, you should memorize the log values. Okay. So please take a note of these things. So in all the questions, they will not give you the log value. So you should know the values for some numbers, and these are those numbers. Got it? This is for the pH formula to find out the for strong acid and strong base combination. Now we will go ahead with the pH of weak acid and weak base. Okay. So let me start with the dissociation of weak acid. So I have a container, okay, and I have some solution inside it. That solution can be water, okay. Now I am going to add a weak acid, okay. General formula for weak acid is HA. So what is meant by weak acid? There won't be any complete dissociation. There will be only partial dissociation, okay. Those acids are called as weak acids. So you see here, I have 3 HA. Only one HA has got dissociated into H plus and A minus. The remaining 2 are there in the compound. Okay, here you see H plus, A minus, and I have HA also. So the partial dissociation of the acid is called as weak acid. Okay, let me show this in a equation form. HA is added to water to give H3O plus and A minus. Now, the equilibrium constant, okay, or the dissociation, acid dissociation constant for this reaction is equal to C alpha square, okay. So, where C is the concentration and alpha is the degree of dissociation. Alpha is the degree of dissociation. So there are a lot of derivations, but I skipped all the derivations for you and I have brought the final answer, final relation for you. So that you can understand and you won't get confused, okay? So please try to understand what I'm trying to say. C is the concentration and alpha is the degree of dissociation and Ka is the dissociation constant of acid, okay? So this is a formula you have to use to find out the dissociation constant of acid. In some questions, they will give you the Ka value, okay? And you will be asked to find out the degree of dissociation. Mostly, you will be asked to find out the degree of dissociation only, okay? So just remember this formula. We can rearrange and find out the value of alpha. Got it? This is the first formula. And the second formula is finding the pH of weak acid. So the pH is equal to 1 by 2 into pKa minus log C. 1 by 2 into pKa minus log C. This is the second important formula you have to keep in mind from this topic. Okay. So what is meant by Ka? Ka is called as dissociation constant. But what is the meaning? It is the measure of the strength of the acid. Ka is the measure of the strength of the acid. If the Ka value is larger, then the acid is stronger. Okay? Then the acid is stronger. So Ka is directly proportional to acidity. Ka is directly proportional to acidity. If the Ka value is larger, then the acid is also more strong. Okay, acidity is also strong. Clear? So Ka is directly proportional to acidity. So from this slide, you are taking two formulas and one relation, and all the three are very, very important. Do you have any doubts from this? Shall we go ahead with the next slide? Students, any doubt from this? Shall we go for the next slide? Yes? Okay. Fine, fine. Now we will go ahead with one question. Okay, calculate the pH of 0.01 molar acetic acid solution. Acetic acid means CH3COOH. Also find its degree of dissociation. Also find its degree of dissociation. And the Ka value is also given. Okay, so we have the Ka value. And what is this? What is meant by 0.01 molar? It is the concentration value. We have Ka value, we have concentration. We are asked to find out the degree of dissociation alpha. So how to find out? So the given values are Ka, and to find out the degree of not only degree of dissociation, we also have to find out the pH, right? Calculate the pH. We have to find out pH. We have to find out pH as well as alpha. So first let's find out pH, then we will find out the degree of dissociation. So what is the formula to find out the pH? pH is equal to 1 by 2 pKa minus log C, right? Log C. So now what we have to do, we have to find out pKa, because we don't have pKa, we have only Ka value. To find out pKa, the formula is minus log of Ka. To find out pH, what we have done? We have did minus log of H plus, right? So in the same way, to find out the pKa, you have to do minus log of Ka. So if you apply the Ka value here and after doing the logarithmic calculations and all, we will actually log 1.8 minus of log 1.8 plus log of, you have to apply log to both the component. So it will be minus of log 1.8 plus log of 10 to the power minus 5. Okay. So 1.8 can be round off to 2. Okay. So what is the log 2 value? It is 0.3. And what is log of 10 to the power minus 5? It is minus 5. Okay. So what is 5 minus 0.3? 5 minus 0.3 is equal to 4.74. 4.74. So the pKa value is equal to 4.74. Okay. Now apply this in the pH formula. We know that the pH is equal to 1 by 2 pKa minus log C. So substitute 4.74 in place of pKa and 0.01 in place of concentration. Okay, because the concentration is 0.01. Now what is this log 0.01? It means, can anyone tell me what is 0.01? It can also be written as 10 to the power minus 2, right? 10 to the power minus 2. The answer will be minus 2. Log of 10 to the power minus 2 is equal to minus 2. Okay. So already I have 4.74. And here I am getting the answer as minus 2. So already I have one more minus here. So minus into minus will become plus. So plus 2. So what is 4.74 plus 2? 6.74. 6.74. 6.74 divided by 2. Okay. So the answer will be 3.37. This is the pH value. So I have calculated the pH. I have calculated the pH using the formula. So in the pH formula, I need pKa. So I have calculated the pKa using this formula and I have got the answer. Now to find out the degree of dissociation, what is the formula to find out it? Ka is equal to C alpha square. So what is alpha from this? It is root of Ka by C, right? Root of Ka by C, and I know the value of Ka and also I know the value of C. Substitute everything which is given in the question and take out the root. You can also take this as 10 to the power minus 2. Okay. You can cancel this out. And if you cancel this, you will get 3 here, right? So we will have root of 1.8 into 10 to the power minus 3. And taking the numbers out from the root, you can have 4.24 into 10 to the power minus 2. Or you can stop the question up to this also, no problem. Okay, clear? So this finding out the degree of dissociation is the very easy thing. And calculation of pH is also very easy, but before that you need to do this step. That's it. Clear for all? So this is all about the dissociation of weak acid. Dissociation of weak acid. So now let's go for the dissociation of weak base. Weak base. So MOH is the general formula for a base. Now if I add this base to the solvent, some partial dissociation of base will be there. Okay. So if I write this in a reaction form, MOH gives M plus and OH minus ion. And here you can see Kb is equal to C alpha square, where Kb is the dissociation constant of base. Okay, for base. And to find out the POH, it is 1 by 2 pKb minus log C. The only difference is there we have used A, right? Here you have to use B, that's all. There pH and here POH. This is the only difference you have to have between these two. The remaining things are same. But the very important difference is Kb is the measure of the strength of the base. But larger the value of Kb, stronger is the base. So Kb is directly proportional to basicity. Kb is directly proportional to basicity. Okay. If the value is larger, basicity is more. Got it? So this is all about these two. Kb and POH and their Ka and pH. All right. So now we will enter into the factors affecting this acidic strength. So what are the factors affects the acidic strength? Very important. Acid means there are two types of acids. One is strong acid and the other one is weak acid. The example for strong acid is HCl. HCl, why it is called as a strong acid? Because it undergoes complete dissociation. All the H plus and Cl minus will get dissociated in the solution completely. Right? They will get dissociated completely. If I go for weak acid, CH3COOH, this does not dissociate completely. This does not dissociate completely. You can see only very few compounds have got dissociated and two other acetic acid has not dissociated properly. Okay, so we have 3 species in the substance. Now, what are the factors affects this strength? The very first factor is the group number 17 elements. Fluorine, chlorine, bromine and iodine. And 9, 17, 35, 53 are the atomic numbers of those elements. Okay. So if you look into the size of these 4 elements of group 17, fluorine will be smaller in size. And on moving down the group, the size will increase. What will happen? The size will increase. So if I compare HF, HCl, HBr and HI, the acidic strength follows this order. If the size increases, then it is a strong acid because the bond length will be very weak. Bond length is more, bond strength is very less. So the H plus and I minus can be dissociated easily. Okay. But in case of HF, since the size of the fluorine is very small, this bond length is very short and the bond strength is more. It is a strong bond. So hydrogen and fluorine cannot be broken down so easily and they will be present as a weak acid. It is called as a weak acid. Got it? HI is a strong acid. HI is a strong acid. So here I have written strong. Bond is strong. Okay, here the bond is strong. And here the bond is weak. So it is a strong acid. All right. So the very important factor is the size of the halogen or the size of the atom in the compound. Okay. So next we will go for the common ion effect. What is common ion effect? So for this, I am going to take an acid which is going to be in equilibrium with its ions. So Ha is in equilibrium with H plus and A minus. Okay. Let me take a beaker and here I have CH3CO minus ion and H plus ion. So what is the acid then? Acid is CH3COOH and it is in equilibrium with H plus and CH3COO minus. And these two are the ions present in the solution. Now, if I add ammonium acetate, this compound is called as ammonium acetate. If I add this ammonium acetate compound to this solution, what will happen, you know? Ammonium acetate also has CH3COO minus and NH4 plus ion. Now, what will happen inside the beaker? In addition to these two ions, we also have some ions from ammonium acetate, from the ammonium acetate. Already we have acetate ion, CH3CO minus ion. And from the ammonium acetate also, we are getting the acetate ion. Got it? So now, according to Le-Chatelet's principle, we have studied Le-Chatelet's principle, right, in the chemical equilibrium. According to Le-Chatelet's principle, the equilibrium, on addition of this particular compound to the system, the equilibrium will shift towards the left side. Equilibrium will shift towards the left side. That is, on addition of common ion in solution of weak electrolyte means weak acid. CH3COOH is a weak acid, right? If I add the common ion in a solution of weak electrolyte, its dissociation decreases. Its dissociation decreases. So this compound also has acetate ion and the weak acid also has acetate ion. If I add this into this, the dissociation of this weak acid is decreased. You see in this beaker, acetic acid is remained as acetic acid here. It doesn't get dissociated. If I add this compound, the dissociation is getting decreased. Got it? This is called as common ion effect. Acetate ion is common to both. Because of this common ion, the dissociation of the acid decreases. Clear? And also, if I want to find out the dissociation constant alpha for common ion effect, then I have one formula to find out. It is alpha is equal to Ka divided by Cs. Ka means dissociation constant of acid and Cs is the concentration of the solution. Concentration of the solution. Got it? This is the very important formula. Alpha is equal to Ka divided by Cs. Okay. Able to understand the common ion effect, students? You want me to repeat again or is it clear? Just Note down the formula and note down this point. If I add one compound which is having the common ion, similar type of ion, then it will decrease the dissociation of the acid which is already present inside the beaker. That's all. And the equilibrium will shift towards the left-hand side. Clear? Shall we solve one question from this concept? Yeah, listen. Find the degree of dissociation of 0.01 molar acetic acid solution. So what we are supposed to find out? Find the degree of dissociation, alpha. And the concentration is given. Concentration of the solution is given. Also find its degree of dissociation in 0.01 molar CH3COO solution. We have two solutions. We are asked to find out the degree of dissociation for both. But we are provided with only the Ka value for acetic acid, not for the sodium acetate ion. So let's go ahead. Let's go ahead with the solution. So first, let us find out the degree of dissociation for CH3COOH. So for 0.01 molar CH3COOH solution, alpha is equal to, we have studied no, how to find out the degree of dissociation for weak acid. It is Ka is equal to C alpha square. So what is alpha from here? It is root of Ka divided by C. So using this formula only, we are going to find out the degree of dissociation. Root of Ka by Ca. Substitute the value. Ka is here and the concentration is also given. And if you substitute and take out the answer, you will get 4.24 into 10 to the power minus 2. Okay. Now what we have to do? We have to find out the degree of dissociation for CH3COO. This is the substance which has been added. It is a salt. It is not a weak acid. So here we have to use the common ion effect. So this particular ion is common, right? So alpha dash is equal to Ka by Cs. You should not use root here. So substitute the value of Ka and the concentration. Concentration is same for both. Concentration is same for both, right? So just substitute the value and what we will get? It is 10 to the power minus 2. And if we cancel this, we will get 1.8 into 10 to the power minus 3. Clear now? Can you able to differentiate between a weak acid and the salt? Any doubt? Okay, very good, Kartika. What about others? Students, can you all able to understand? So mostly this ionic equilibrium also contains formulas only. Okay. So just listen to the class very keenly and write down all the formulas and keep it with you. Revise and solve the questions. You will get practiced through the question solving session and you can get the good marks from the ionic equilibrium part. Okay. It's very easy. Now the next concept is salt hydrolysis. So under this, we are going to learn the types of salt, hydrolysis of 3 combination of salt. Okay. One is strong acid and weak base. Second is weak acid and strong base. Third is weak acid and weak base. Okay. One combination is not given and we cannot find out the hydrolysis of that salt also. Can you find out what is that combination? What is that combination? It is strong acid and strong base. Okay, we will not study the hydrolysis of this combination, but the other three will be discussed. Clear? So, before moving on to this, I would like to give one example for each. So, we have strong acid, weak base, weak acid, strong base. Or I will go in this way. So, let me not confuse. So, let me go strong acid, strong base, weak acid, weak base. So the example for strong acid is HCl. And the example for strong base is NaOH. Okay. And the example for weak acid is CH3COOH. The example for weak base is NH4OH. So please take down these examples in your notebook. Okay. Otherwise, when I use the term strong acid, weak acid, strong base and all, you will get confused. Okay. So have these examples in your notebook for each case to avoid the confusion. Okay. So if I say strong acid, then you should know that I'm talking about HCl, and HCl is given in the slide. Okay. In your book also, the same thing will be followed. Have you all finished writing this? Shall we go for the first topic, which is types of salt? Shall we go for the types of salt topic? Okay. So, first of all, if acid is reacting with the base, it gives salt and water, right? Acid is represented by Ha, base is denoted by BOH. And they give AB type of salt and H2O. So I have H plus and A minus in acid, okay? And a B plus OH minus in a base. And we have the salt AB and H2O in the container finally. Okay, this is salt. Let's go for the first type of salt. First, let me go for the salt of strong acid and strong base. We will not study the hydrolysis of this combination, but I would like to give you the reason and some examples of this combination. Okay. Now, the cations of strong base and anions of strong acid. Cations of strong base, anions of strong acid. What is an example for strong base? I told you, right? The example for strong base that I have given is NaOH. It has Na plus ion and OH minus ion. Okay? So, Na plus is the cation. Positively charged ion is called as a cation. So, Na plus is the cation of this strong base. Okay? And what is the example I gave for strong acid? HCl. So it has H plus and Cl minus. It has H plus and so the example for strong acid is H plus and HCl. So it has H plus and Cl minus. So the anion of the strong acid is Cl minus. Okay. So these two combination will give the strong acid and strong base salt. Okay. So Na plus and Cl minus will come together and they will form NaCl salt. And this salt is a combination of strong acid and strong base. Okay. So like this only, they have taken this calcium 2 plus, potassium plus, and here Br minus, NO3 minus, and ClO4 minus and all. Okay. So these two species combination will get hydrated, but they do not hydrolyze. They will get hydrated, but they do not get hydrolyzed. So what is the difference between hydration and hydrolyzation? Hydrated means, for example, if I have NaCl, NaCl can have 2 moles of H2O with it. This is called as hydration. They get hydrated. Okay, they can add this water molecule with them, but they do not hydrolyze. They will not react with water. They will not react with water. Okay, they do not hydrolyze the other species, but they will get hydrated. And because of this reason only, we don't see the hydrolysis of the strong acid and strong base combination. We don't see the hydrolysis of strong acid and strong base combination. Okay. Since the species cannot hydrolyze, we cannot see. So now let's go ahead with the second type of combination. Salt of weak acid and strong base. So what is the example for weak acid? Example for weak acid is CH3COOH. What is the example for strong base? NaOH. So now take these two combination. You will end up with sodium acetate. If you remove this water, you will get sodium acetate, right? So this sodium acetate has acetate ion and sodium ion. So one cation and one anion. So if I take this acetate ion and treat it with water, it will be in equilibrium with acetic acid and OH minus. So how do I get these two species? So water molecule has H plus and OH minus. Okay. So acetate ion will take the H plus and the remaining OH will be present here. Got it? So the first molecule remains unionized. The second molecule, that is the OH minus ion concentration, increases in the solution. OH minus ion concentration increases in the solution. Okay. So this is the salt of weak acid and strong base, and they undergo hydrolysis. Okay. So now we will go for the third combination. Third is salt of strong acid and weak base. So what is an example for strong acid? HCl. And the example for weak base is NH4OH. This is what we have seen, no? So take these two compound. We will get NH4Cl as a salt, right? If I remove the water, I will get NH4Cl. And this NH4Cl has NH4 plus ion and Cl minus ion, cation and anion. If I take the cation and treat it with water, I will get NH4OH, H plus and OH. So NH4OH will come out and the remaining H plus will be there. So NH4OH remains unionized and H plus concentration will increase. Okay. So why this NH4OH will remain unionized? Because it is a weak base. So it's partial dissociation. So it remains unionized. But the H plus concentration will increase in the system. Got it? Now we will enter into the last combination, weak acid and weak base. So weak acid example is acetic acid, and the weak base example is NH4OH. Okay. So if I react these two molecules, I will get ammonium acetate ion by the removal of water. Okay. And this ammonium acetate has acetate ion and ammonium ion. And if these two ions are treated with the water, they will produce, water has H plus. and also OH minus. Acetate ion will take this H plus and the NH4 will take OH minus. So they will form this product and these two will undergo partial dissociation because both of them are weak acid, right? Weak. Both of them are weak. So they will undergo partial dissociation. Got it? So this is all about the salts of 4 combinations of acids and bases. Okay. So now we will solve this question. Answer is also given here. Which of the following salts will not hydrolyze? So which salt will not hydrolyze? The salt of strong acid and strong base combination will not hydrolyze. Okay. So the answer is BaCl2. Why? Because it is a salt of HCl, strong acid, and BaOH, twice strong base. If you look into the other molecules, CH3COONA, it is a salt of CH3COOH and NaOH, right? COOH is a weak acid and this is a strong base. So they will hydrolyze. And here NH4OH and HCl. It is a salt of NH4OH and HCl. NH4OH is a weak base and this one is a strong acid. So this combination will also get hydrolyzed. And here if you see, it is CH3COOH and NH4OH. So this is a weak acid and this one is a weak base. So this combination will also get hydrolyzed. So the only combination which will not get hydrolyzed is strong acid, strong base. Okay, BaOH twice and HCl. Got it? Can you able to understand? Any doubt, students? So I already told you to avoid the confusion, keep the examples which I gave for strong acid, strong base, weak acid, weak base. Clear? Yeah. So now we will go for the pH calculation. I have skipped the derivation part of the pH formula, okay, for this hydrolysis of 3 combination, and I have taken the final formula for you, okay. So just take down the formula for these 3 combination where pH is equal to 7 minus half of pKb plus log C for acid base, strong acid weak base, and 7 plus half pKa plus log C for strong base weak acid, and 7 plus half of pKa minus pKb. So in the last formula, there is that we won't use the logarithmic function and the concentration. Okay, it is just pKa minus pKb, and that is for weak acid, weak base. These are the 3 formulas you are going to learn for these 3 combinations. Okay, so let me summarize. The salts of strong acid, weak base, weak acid, strong base, weak acid, weak base. So these 3 combination will undergo hydrolysis in aqueous solutions. Okay, point number 1. The last combination, the salt of strong acid, strong base, do not undergo hydrolysis. So the pH of all the solution which has this type of salt will be 7. Okay, 7. The pH will remain unaffected. It is 7. And if you have to find out the pH for the remaining 3 combination, you have to memorize these 3 formula. Okay, clear? So with this, we will go ahead with one question from this concept so that you can understand better. Okay. Shall I go for the question? Shall we calculate the pH of a salt? Yes. Yeah. The pKa of formic acid and the pKb of ammonium hydroxide are given. Calculate the pH of ammonium formate solution. The pKa of formic acid and the pKb of ammonium hydroxide. Formic acid means weak acid. It is an example for weak acid. So formic acid formula is, I will give you the formula, okay? Formic acid means HCOOH. And ammonium hydroxide, you all know. What is the formula? It is ammonium hydroxide means NH4OH. So it is an example for weak base. It is an example for weak base. This is for weak acid. So the salt that is going to get formed from these two combination is called as ammonium formate. Ammonium formate. So we have to find out the pH of this ammonium formate solution. So what formula, which among the three formula we have to use for this combination to find out the pH? Can anyone tell me? pH is equal to, yeah, very good, Roshan. It is third formula. pH is equal to 7 plus half of pKa minus pKb. Now, after this, everything is a direct substitution. Find out the answer first. Find out the answer first. pH is equal to 7 plus half of pKa is 3.74. pKb is 4.75. Just subtract. You will end up with minus 1.01. And if you take half of it, it will be 0.505. 7 minus 0.505 is 6.495. So this is the pH of the given solution. Okay. So it is somewhat near to 7, right? But still it is acidic only. It is acidic. 6.4 is acidic. Okay. Clear? Students, can you able to understand how to apply the formula? How to apply the formula from the hydrolysis to find out the pH? Any doubt? No doubt? Okay. So today we have discussed the entire hydrolysis topic. Okay, the entire salt hydrolysis topic we have covered today. Okay, along with that, some parts of the previous concept also we have studied. So we have one more big topic left in this lesson, which is called as buffer solution, that we will discuss in the next class. Okay. So thank you so much for attending the today's class. See you all in the next class. Before that, I have launched a poll. So give me your answers in the form which I have given, and then you can leave the class. Okay, thank you. Thank you. Bye.